are not here, right? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. There's 15 of you here. There's 22 of you.
Wait, then that's 16. Hayden.
So this is one class. I have 7 gone, and I got to keep up with you guys with your work. So what it does is it puts the burden on you when you're gone. You've got to keep up when you're gone, and you've got to touch base with your teachers when you come back and while you're gone. You have to do that because our absenteeism is only going to get worse this winter. Because, I mean, you know what it's like. You're seeing it. You're out with a sniffle, you're out for, is it 2 tests? You got to do 2 tests or 10 days?
10 days.
10 days. Or 1 test. Okay, so, you know, that's anywhere from a week. I took a test last Tuesday. When did we test last week? Tuesday or Thursday? Thursday it was offered? Okay, I took a test Thursday. I haven't seen the results. I took a test a week and a half ago. It took 8 days to come back. So, you know, you're out for a long time. And you got to keep up with school. You can't say, oh, I'll catch up when I come back. That might not ever happen. So stick with the regimen. And you all know how to find the work, right?
Yes.
Go to Classroom, and the first link on the top is all of your daily stuff. Really? No, her, girl behind you. Yeah. Yeah, you can't. You're in a tough situation. But if that happens, we go back to the can. Your mom's got to talk to me. So for you, yeah, you're unique because there's no way to have internet or anything at home. But if you are out, have your mom get a hold of me because we email. We have each other's phone numbers too, so we can text. And I'll figure out a way to get to you what we need to get to you. Okay? Just don't get sick.
What does THV?
Oh, it's like X and Y and another Y. Has nothing to do with us. This is all in algebra. It's just comparing 2 equations at the same time. Sir?
I read it last night, but I don't understand it at all.
Okay, grab a pencil. So, models for addition. Yeah, some of this we're not going to understand because we haven't been learning from this textbook series. And if you get into one textbook series, they start using kind of the same ways to describe things. And you haven't seen this before, so it's understandable. That's okay. And I guess that's why I'm here. I'm going to help you with it a little bit as we go. But then next year when you're in the algebra book, you'll say, oh yeah, I've seen it look like this before. It will look very familiar and so on and so forth. And by the time you're a senior, you'll be an old pro. So they have different models here. And one of them that they say that they have, a way to look at adding numbers, is putting together. That's kind of what we do. When we put numbers together, we're adding. So that's the most simplistic form. There's nothing that's supposed to be complicated about this in any way, shape, or form. But what they do is they show us that we can put together things in different ways. So for example, in the first example, they say if we had 2 pounds and 14 ounces, and we were going to put those together, we were going to add them together, we can either say we have 2 pounds, 14 ounces, or we could change pounds to ounces, or we could change ounces to pounds. So how many ounces are in 1 pound? 16. So we could think of this as 32 ounces. You put them together, now you have 46 ounces. Or you could have 2 pounds, and 14 out of 16 ounces is what this is. So this would be 14/16 of a pound. So that comes into 14/16 is what fraction when it's simplified? 14/16. Yeah, that's gonna be 7/8. So here we have 2 7/8 pounds. Up here, we put it together and we have 46 ounces, same. That's just an example of putting numbers together, that's all. We've been doing this for a while, right? Nothing new, we're just gonna make it look a little bit different with some of the examples. And then, if you do not have this written down, this is something that's kind of obvious, but we give it a name because when we get into higher math, we use some of these names to prove other things that are more complicated. And the betweenness property, if you have 2 points, like this, and then you have a segment, and then let's say you have a 3rd point in the middle. So I didn't put them in order A, B, C. So here's the segment A to C. Hey, how about if I change the C to an M? Let's do that, because it's in the middle, it's in between them. We could say that this length added to that length makes the total. So if I add those together, I get the total length. We've been doing this, right? You measure how long one object is, how long another object is, you put them together, you know how long they are collectively. But we can write this more formally, and that's what the property gets to. So if we looked at this segment from here, from A to M, if we write just AM without any symbol above it, that means how long AM is, the length of AM. So this means, so now what I'm going to do is I'm going to put a bar over the top or a little segment notation. This is the length of segment AM. I'm not writing very neatly. Here. So this is the length of segment AM. And then if I wrote MB like this, that would be read the length of MB, because there's no line over the top or an arrow or anything saying that it's a ray or a line or a segment. And if I say plus, what would I write over here as far as what the total length is? So I've got AM plus MB equals, and how do I, AB, yeah. And something that you might notice is that each of these have that M within their name. So that's like a common point. It's a place where one of these ends and the other segment begins. So it's a geometric way of writing. And let's say that this was 4 units and this was 4 units, well, it'd be 4 plus 4 is 8. But that's the betweenness property. And then they go and they say that we can do the same thing with angles. So some of your work is not going to be just adding numbers together, but it's going to be adding the measurements of angles. So the angle addition properties. Let me use the same notation that the book uses. So they have O, P, N, How many angles are there that I drew?
Three.
3, good. 2 little ones and 1 big one, right? And the 2 smaller angles add up to the whole. So what we can do here is we can say that angle, that's not a less than sign because it's flat on the bottom, PON added to NOM is going to be equal to which? So the 2 small ones add up to, which is called POM.
Wouldn't it be like 4 angles because of E all the way around?
Going this way?
Yeah.
Yeah, you can get into a big, long discussion on that one. Come hang out the last period of the day most days. We do that in geometry. We had quite a discussion. Yeah, you could have this one here. And that would be an exterior angle. These would be interior angles. Sure. Usually we talk about interior angles. We think about the ones that are smaller than 180 degrees unless we specifically state otherwise. But now, look at this here. You have ON and NO. And the O is in the middle, which is the vertex, always. And so this is segment ON, which is one side, and PO is the other side of the angle. So we can look and see that this ON and that NO are common sides. That's the side right here in the middle. And then, I'm trying to think. So, okay, I'm mixed up on which is in which lesson. Okay, slide model is another model. This is the one that you guys are probably most familiar with, because we used this a bunch last year. Remember when we set up the number line on the floor? And you had to like face in a positive direction and then
Oh, yeah.
walk backwards and stuff like that? And it was,
Yeah. With the dice?
yeah, or a spinner, and it'd tell you which way to face and then which way to move, and we were adding negatives and subtracting negatives and doing things like that. Well, the slide model is what we were using because we were sliding up and down the number line that was in the room. And we can probably write it more simple, and this book chooses to do that. What the book does with this is it takes a number line. Whether the number line is vertical or horizontal, it doesn't matter. But if the number line is vertical, going up is positive and going down is negative. And going to the right, if it's horizontal, is positive, and to the left is negative. In example number 2 uses this. It says Alex is on the 4th floor of a large department store. He takes the elevator up 5 floors and then down 2. Which floor is he on? So if we were to model that with a vertical line, so if this is the ground floor, here's the 5th. He's on what floor?
He's on 4.
He's on the 4th.
He's still in the elevator because you can't decide which floor to step on.
Yeah, so what we do is we say, well, here's where he starts. He's on 4, and then he goes up 5. 1, 2, 3, 4, 5. So this is plus 5. And then he comes down 2. Subtract 2. So what's being modeled here is starting on 4, adding 5, and then subtracting 2. But if we look at that line, it's a negative 2 length. So we could also say it's adding a negative 2 instead of subtracting 2. And then where do we end up?
7.
Right there, 7. So it's just a way of modeling or a way of looking at subtraction and addition. you don't have to look at it this way. What we're doing with this is we're presenting a couple of different ways to look at addition and subtraction, and then you choose what works best for you. That's where I'm coming from with it, at least. Phoenix.
I didn't know one. You
Okay. So if we used something like this with a slide model, in the third example, it says a family owed $1,200 on a credit card, and then they charged $45. And what we're supposed to do is write an addition property, and then figure out how much they owe. So how do you write this as an addition problem? If they owe $1,200,
-$1,200 plus -$45.
yeah, it's negative 1,200, because when you owe, that's a negative. And then you charge 45. What do we do now? Subtract or add? Add a negative, yeah, because now we add more going down. Okay. So if you're gonna do this with a slide model, you might think of it, just picture yourself, you're at negative 1,200, now you gotta become more negative. So in this case here, all you have to do is add together 1,245. They're both negatives, and that becomes your sum. So it's a negative 145. Yes?
So that's a lot of money to me.
Yeah, it's a lot of money. All depends though. Maybe they have a lot of money. Maybe they can afford to do it. The key is to never, ever not pay your credit card bill when you have a credit card someday. As long as you keep paying it, you're okay. It's when you don't pay. That hurts. Because they charge a lot of interest on credit cards. Very, very high interest. And sometimes it's 20% or more per year. So that means if you owed $100, at the end of a year, you'd end up having to pay more than $120 if you're not paying. That adds up fast. So then there's the commutative property. Just be aware of it. I think you already are. I don't know if you need to write it or not, maybe. Not commutative, it's commute, because commuting is moving. Commutative property. So for addition, it just simply means that we can reverse the order of the numbers we're adding, and we're going to get the same result. So what they do is they note this as A plus B, two numbers, two things that we're putting together, can be put together in the opposite order, and you end up in the same place.
And you can do that with all numbers?
You can do that with all numbers, you bet. What's 3 plus 7?
10.
Right? What's 8 plus negative 5?
3.
Negative 5 plus 8? Negative 3.
Yeah.
Oh, positive 3, yeah.
Well-
So it doesn't matter. If you're at a negative 4 plus a negative 8, that's still equal to a negative 8 plus a negative 4.
Wait, why? So for the 8 plus negative 5, why isn't the negative 5 in parentheses on the? Oh, it's okay.
Because I'm not trying to separate two symbols. Yeah, you could do it. Same. It means the same. It's just a way of separating symbols. So, on a slide like this, whether you do the negative 2 or you do the positive 5, you end up in the same place. You end up right there. You could start here, you could go down 2, and then you could come up 5. So if you came down 2, and then you went up 5, you're going to end up in the same location. That's commutative.
So
with test.